Hello, we are SP-5-Blue-Grocery, and today we want to showcase our final project, Listin, a grocery list editing app. Here's what we will cover today. First, we will talk about the basics of the project. Then we will discuss the early and late stages of the software development lifecycle. We will talk about the build development and its actual implementation, and cover the project status of the current final build. Then we will close out. Here are the team members in each of their roles. I am Jack Lusk, and I was the project lead, and I also handled documentation.
I'm Amaya McCullough, and I was a developer.
My name is Jason Apollon. I was also a developer.
We also had Malik Obi as a member who handled documentation and did some visual design. Now, let's talk about the project. Here's a quick overview. The grocery list app Listin is an app for managing and editing grocery lists. You can create an account and then add and remove items from grocery lists of your choice. What's neat about the app is that all updates to grocery lists reflect automatically in real time because the app is connected to an online database. Related users can even edit and share the same list. The goal is to enhance the shopping experience by providing a convenient electronic grocery list. Here's the initial concept behind the app and some of our brainstorming on it. The idea was a lightweight, user-friendly grocery list that anyone can use. The app has two core components. First, you can create a grocery list through a simple, sleek interface. Then, you can add items to that grocery list through a detailed item catalog with images. These two simple steps make the app very accessible. Another core idea was that family and friends can create and share the same lists. One idea was that a father could send his son grocery shopping, but if he forgets an item, he can simply edit and add it to the shared list and the son will see it. Very convenient. Here are the design goals of our application. Collaborative lists that multiple people can edit, full CRUD operations for managing lists and grocery items, user authentication, real-time synchronization of all data, a detailed item catalog with images, and cross-platform deployment for both iOS and Android. Now, let's move into the actual software development life cycle. Here's some of our requirements analysis in terms of functional and non-functional requirements. These are user login and registration and user account authentication, grocery list management for creating grocery lists, deleting grocery lists, and adding and removing items from those lists, as well as the item catalog that holds all the items. In terms of collaboration, you must be able to share lists between users, and all updates to shared lists must occur in real time. Finally, the user interface should allow navigation between all screens immediately and have images for all items. Some non-functional requirements we defined were HTTPS security for data transmission, real-time updates, ideally within 1 to 2 seconds, but possibly within 4 to 5 at the latest. And finally, support for both Android 8.0 and iOS 15 Plus compatibility. Now, based on the requirements, we developed software design definition. We use an object-oriented design where all core entities or modules, like the grocery list or item catalog, were encapsulated as classes. Then they were iteratively prototyped and integrated into the development environment one by one based on functionality. We use a Flutter reactive framework with a client-server architecture to support the real-time updates and connection to the database. Finally, in terms of end-user characteristics, we assumed a wide range of skill due to the simplicity of the application. Over here, you can see our modular architecture, starting with the highest abstraction UI layer down to the network and service layer. Here's the methodology behind some of our design choices. As discussed slightly earlier, we use a component-based software development approach where each component or module was individually encapsulated, then integrated into the environment. We had a strong software design specification defined early, which enabled development of both the front end and back end to move smoothly. We actually implemented the database connection module first and then designed all modules after that, which made development very smooth. Popular grocery apps like Publix's app were used as inspiration for the UI. Now, here's some early mock-ups we had for our user interface design. You can see on the left here, for example, the item catalog UI mockup. These were all made in Figma and served as very strong inspiration for our app's actual UI. Here's the actual development of our build. Here's what we use for our development. We use Flutter and Dart for the programming, Firebase for our online database, Firebase authentication to connect the backend to the database, VS Code is our integrated development environment, GitHub to hold our project repository, and finally Figma for the user interface mockups. Here's why some of these tools were chosen for our development environment. Flutter and Dart were selected simply because they are very friendly for mobile device development. Additionally, Dart has very strong asynchronous support capabilities, which helped with the database logic. We chose Firebase because it is an easy to use and easy to update online database and has features for real-time data synchronization. Finally, VS Code was chosen simply because it is versatile and supports both Flutter and Dart extensions.
Our app connects to Firebase using the Firebase SDK. In Flutter, Firebase is initialized when the app starts. I then created a Firestore instance and used it with methods to read and write data to the database.
Here's how you actually set up and run the project. First, you simply download VS Code and install the latest Git package. Nice. Now go to the VS Code Marketplace and download the Flutter extension. Now at the top of the VS Code, open the command palette and select View Command Palette. Then go to Flutter, New Project, and download the Flutter SDK when prompted. Once you've got the SDK, simply go Clone Flutter and add SDK to path. This integrates the Flutter SDK. Now, back at the command palette, run flutter doctor, and this will confirm the installation was successful. This will also automatically install Dart. If Dart did not install automatically, you may have to manually run Dart install. Now you have an empty functional Flutter project. Simply go to the GitHub and download the repository into the empty project. You can now run the project in a browser window or on a mobile device if you connect it via USB. Now, we'll talk about the actual implementation of the build. This is the first module, account.
In this module, we focused on making sure the user could create an account and log into the app. We used Firebase authentication to securely handle user login and registration. When a user creates an account, Firebase assigns a unique user ID. This ID links the user to their data in the database. In this module, we focused on making sure the user could create multiple grocery lists and add various items to those lists. We achieved this by using several methods to edit the Firestore database. When a user creates a list, the app sends a request to Firestore to create a new document. We use Stream so that the UI automatically updates whenever any data is changed.
For this module, we built an item catalog connected to Firebase. Everything pulls in real time from Firestore. We also integrated Firebase storage so product images load dynamically and items are organized into categories based on the database. In terms of functionality, users can search and filter items easily, browse by category, and navigate between catalog, aisle, and item detail screen. Overall, this module focuses on making the catalog fully dynamic, interactive, and connected to real data.
The database is structured into three main collections. When a user registers, any relevant info that we may need is stored in the user's collection. For example, their user ID, name, and email. The item catalog collection is already populated with common grocery items, and the grocery list collection stores any list created in the app. List documents are linked to users using a field titled Owner ID, which contains the user ID of the person who created it. Items are stored as a sub-collection inside each grocery list document. This helps us keep related data grouped together.
For this module, we focused on building the full user interface and connecting it to the backend. The catalog UI is fully integrated with Firestore, and we use Stream Builder to handle real-time data updates so the UI always reflects the latest data. We also designed category-based browsing with horizontal scrolling, making it easy for users to explore items by aisle. Search functionality was added to filter items instantly as the user types. On the product side, we created a detailed item screen that includes images, pricing, and quantity selector, along with the ability to add items to cart. The cart system is tied to each user using Firebase authentication. Overall, this module brings together the front end and back end to create a responsive, user-friendly experience. For this module, we implemented account linking. Here, users can send and accept invites. This allows multiple users to view and edit a shared list. This list reflects real-time data updates, so users can leave or be removed at any time.
Now, let's talk about the project status of our current finalized build. Here's our development progress. All 6 modules, as you can see on the left, are 100% complete and fully integrated. Nice. The user interface is also fully functional and pulls all widgets and data with the live updates from the database. The Firebase connection to the database has been finalized, and all 3 database sub-collections have been completed for user accounts, user lists, and item catalog items. Overall, development went really smoothly. The prioritization of the database connection modules early was the key to the smooth development. The current build achieves all required functionality and is extremely stable. Thorough testing was conducted on all modules to achieve this. Here's some details about our actual testing. Testing actually occurred pretty late in development when the majority of modules and features had all been completed. Each module was first tested on its own, then modules were combined to test integrated functionality through integrated testing. The majority of our test cases actually focus more on functional testing or data validity testing because we feel these aspects were the most important. We also place special emphasis on testing functionalities that use the database in some way. The initial test report result was extremely positive, with the majority of test cases passing, indicating the build was near completion. Additional rounds of testing were conducted on the account linking module since that was added last. You can see on the right here our types of test cases and some of our test scenarios. Here are some details of our current build. These are all the features we've completed, as you can see here. Full grocery list CRUD. The home screen and add item screens are wired using Firestone service to update automatically. The item catalog pulls all items live from Firebase with no hard-coded data. The search bar is functional, allowing you to search for items, and all items have a price, image, and correct name associated. The Firebase authentication works to authenticate all user accounts and provide security. And finally, last but not least, we fully integrated the functional account linking for sharing lists. What we are currently working on, though the build is still complete, is adding a few additional items to the catalog to improve variety. What we are planning for a potential phase 2 of development is a dark mode and foreign language support, as well as a recommendation feature for the catalog, where a few items that the user might like or has bought before will appear at the top of the catalog for them to select. Here is the finalized control flow diagram for our final build. The user first creates an account and then logs in, where they are brought to the grocery list management page. From this page, they create a grocery list and are moved to the item catalog. Here, they select the items they want to add to the list and move to the session cart. At the session cart, the user can select the list that they want to add the items to, and they will be appended to that list. This is the core operation. If the user wants to share a list, they can move to the account linking page, or they can send an invite to another user to share the list. Then both users can edit the same list, and the updates will reflect for both users in real time. When the user is done, they simply go to logout, select logout, and they are complete with using the app. This is the core functionality of our completed application. Here are some limitations and challenges we faced. As you can see on the left, there are some errors loading item images and they would not display. There was also a bug in the item catalog search where 2 items that were exactly the same would duplicate and appear twice. Overall, there were some minor issues on the back end achieving a stable connection to the database, and sometimes the database substructures, such as the user account structure, had to be recreated and redefined to reflect changes in the app. Additionally, there were some issues integrating the backend and front-end development because they were mostly handled separately by different developers. However, we have overcome all of these issues and created a product that we are proud of. Some steps we are considering moving forward are adding more grocery items, implementing full nutritional details like you'd see on the back of a drink or something for every item. We are also considering some phase 2 features like a dark mode and additional language support. Finally, we are considering preparing the application for actual deployment on a digital distribution platform like the App Store. Now, we will showcase an actual completed demo video of our final project build. Please take a look.
This is our grocery list app listing. It opens on the login screen. First, you must create an account by entering your name, email, and password. Once you are registered, you can log in. Once logged in, you will see the home page where you can add and delete grocery lists. I want tacos for lunch, so this is what I will name my list. Now that the list is created, I can add items. On the item catalog page, I can browse categories or search specific items. Now that the items are added to my cart, I can view the cart and select which list I would like to add them to. Here are the items in my list. Now I would like to share this list with a friend. I can send an invite by choosing which list I would like to share and entering their email. In my friend's account, I must accept the invite before I can see the list. Now I can view and edit the list. I'm going to add a few more items. Here are the changes in the list. If I would like, I could also choose to leave the list. I can also view the changes in the owner's list.
All right, that was our completed project demo video. I hope you liked looking at a showcase of our completed project. Thank you so much. Now, let's close out. Here's a quick summary and conclusion about our application. Our app is Liston, a grocery list editing app where you can do collaborative real-time grocery list management by adding and removing items using Flutter and Firebase. It uses an object-oriented approach with iterative development methodology. Some of the core features are list management, Firebase authentication, Firestore services, and a detailed item catalog interface with a checkout flow and detailed item images. The final key feature to be implemented was the cross-account list syncing for sharing and updating lists. This is fully functional, has been fully integrated. This has been a showcase of Liston, our completed project. We are SP5 Blue Grocery, and thank you so much for listening. We hope you have a great day.